When you test products virtually or in the real world, naturally you're exploring numerous design options and evaluating how long they will last by finding out when and where the ultimate failure may occur. And this is no easy task when simulating numerous physics and loading scenarios. Collecting and making sense of all the data can be daunting and time-consuming. This is especially the case when the design and analysis tools are disconnected or limited, but there is a better way. The 3DEXPERIENCE platform provides a collection of the best in-class simulation apps built with industry-standard leading technology, including Abacus and FE-Safe, which connects seamlessly with SolidWorks. Adam, our analyst, is working on the Nemo submarine to help satisfy the safety and certification requirements when it comes to the battery compartment and skid. He has a few remaining tasks with a depth rating of 100 meters. It is critical that the battery compartment can withstand the pressures beyond this depth to ensure safe operation. At the same time, weight and cost must be reduced wherever possible. Adam considers the thickness of the steel tube and stiffness. He then defines an associated dimensions as parameters that can be optimized. He saves the updated model to the platform and launches the Model Assembly Design app to start the simulation process. First, the mesh is created. The automated FEM recognizes the thin components of the model and creates mid-surfaces and associated shell mesh bodies all in one command. Next, Adam creates a structural scenario that defines the loads and boundary conditions to simulate the maximum design depth rating. At first glance of the results, it is obvious that the structure is over-designed. Adam launches the Parametric Design Study app, selects the parameters and goals of interest, and lets the computer do the rest of the work. When the study is done, Adam can easily interpret and compare the performance of the various configurations. The best design is even highlighted for him, and with one quick a new model and study using the optimal parameters is created, so that Adam can have a closer look. But he has additional tasks to complete first. The pressure load on the battery compartment happens multiple times throughout the life of the Nemo. Another loading condition that repeats is the impact of the skid landing during storage. To simulate the secondary loading condition, Adam creates an explicit dynamic study to accurately capture the rapidly changing stresses of the landing cycle. How exactly does the skid come in contact with the floor? Adam lets the solver figure that out with one simple yet powerful general contact interaction. To greatly decrease the solve time, Adam chooses to run the simulation in the cloud, leveraging its high-performance computational power. Adam can even shut down his computer while the simulation runs. The stress values are within the expected range, but how many times can the Nemo withstand both this and the pressure load? To reveal the answer, Adam has set up a durability study. He defines a fatigue loading that captures both events. For the explicit dynamic results, he includes all increments to account for the fluctuations in response. Adam also includes both stress and strain in the calculation to improve the accuracy and solve for both high and low cycle fatigue. Both sequences occur in the loading history, but they are exclusive events, so he turns on the entire event transition option. Lastly, he defines the base service finish and solves the results. The results are not only available to Adam, but may be viewed by other collaborators from the internet browser, so everyone can get the latest information instantly from one place. Adam's last task is to identify where ultimate failure may occur on the Nemo if it gets too deep. Leveraging the same study setup from the first scenario, he defines a Rix buckling step, which goes further than a typical eigenvalue buckling analysis. This is also well suited to the unstable and nonlinear collapse of the structure, and also doesn't require a more complex dynamic analysis. Processing the results is simple too. Adam plots the load factor and visualizes which areas of the compartment will fail first. By using the 3DEXPERIENCE platform to explore numerous design options, evaluate durability and understand critical loading events, Adam and his team were able to make an informed, timely decision to help fulfill their safety and certification requirements. So in summary, we can see we can automate the optimization process by giving specific parameters for our simulator to use. We also looked at the durability of our model with a comprehensive fatigue study. We also looked at worst case scenarios, which provided us with buckling and collapse information.